Today our discussion will focus on Layer 7 policy enforcement. During the workshop, if you have questions, feel free to type them into the GoToWebinar control panel. We'll read them aloud and respond as we go. If we've moved to a different slide or we miss your question, there will also be a chance at the end of the workshop to ask questions. Next. So let's get started. Today we will discuss configuring and managing Layer 7 network optimization. We will also identify Layer 7 network traffic shaping and get a better understanding of user-level network visibility. We'll show you how to implement user-level Layer 7 SLAs and how to thwart network abuse. Then we'll learn how to read and understand user and application traffic reports. Finally, we'll talk about implementing Layer 7 policy-based traffic shaping. Next. But before we get into that, let me tell you a little bit about Pulse Supply. For those of you who may not be familiar with Pulse Supply, we were founded in 1995 as a distributor of connectivity products, and by the late 90s we began providing IP optimization products for our clients. Exinda is one of our key partners in this area, and we've been solving network challenges with their products since about 2007. Since then, we've had great success with Exinda's products in education, corporate, and enterprise organizations. If you'd like more information about Pulse, our background, or capabilities, I can provide that at the end or follow up after the call. But for now, I'd like to hand the presentation over to Randy Hunt with Exinda. Randy?
Thank you, Ashley. And thank you, everybody, for joining today in today's seminar on Exinda and Layer 7 visibility. To start off with, we want to talk about where Exinda lives in the network in certain topologies. I'm going to give you two examples of different topologies. Although Exinda can be placed in a multitude of environments and different topologies, the most common topologies are topologies with firewalls, as I'm showing now. The Exinda appliance lives as a transparent bridge in the network between your users and the egress point of your network, in this example, the internet. We prefer to be deployed on the inside of the firewall so that we see what we call interesting traffic. Interesting traffic is IP addresses and users that are on the inside of the network. This way you can gain full visibility into the way applications are performing as well as what users are doing through the internet. A secondary topology that I wanted to address today was WAN optimization. In a WAN optimization topology, remote offices that need to access data center resources, such as SIFs or file services, need to connect via either an internet or MPLS or wide area circuit that connects back to the data center. By deploying Exinda appliances on both sides of the circuit, it gives you full visibility as well as the ability to control, optimize, compress, and accelerate all of the traffic that the remote users need to access, whether they're accessing internet through the data center or whether it's a split tunnel type environment. Now I'd like to start into the demonstration. Once we identify with where the Exinda appliance is going to live in the network and how it's deployed, we go into what I call a coffee break implementation. The coffee break implementation for Exinda literally is receiving an Exinda appliance through Pulse, unpackaging it from the packing, placing it in the network where the topology represents what you're looking for, and then once you apply power, the Ethernet connections, and a management port Ethernet connection, you can then go to findmyexinda.com. Once findmyexinda.com identifies with the Exinda appliance, you simply click on the IP address, and from there you can A, leave it as a DHCP address in the network, or statically assign an IP address so that you can manage it from that static assigned IP address. Once you're into the Exinda appliance and once it's placed into your topology, it immediately starts collecting information on what's happening in your environment. We start with a dashboard view. So once I've authenticated to the appliance and I get into what is called our dashboard, I get to see what's happening. It all starts with Exinda's recommendation engine. In this case, under this example network, and this is for the purpose of this example, it is a live network where I will show the control and the mechanisms to identify with users. So I see that MPEG is appearing in my top 10 list for the first time over the last 7 days. I've got Amazon Cloud, GoToMeeting, and IPsec tunnels that are also occurring, as well as an application called RedTube. If you need to discover or find out more about each of these applications, we'll drill into a deeper view as to who's using it, what they're using it for, and what's happening with them, and then apply the appropriate use policy that is important for our environment. Moving from there in our dashboard, it gives me a good understanding based on the application types or application groups that are running within the environment. In this case, when I hover over streaming, I see that 91% of the bandwidth is being consumed for streaming on an inbound for today. If I want to see how it's performed over the yesterday or the last 7 days, I simply go into my date range and adjust the time series. I can also see what applications are leaving the network, streaming, interactive, thin client, for examples. If I'm in a business type environment, I may be interested in how much time is being spent for recreational applications. In this case, whether it's games, instant messaging, and so forth, in my case, I see streaming has been used for roughly 40 minutes and has consumed just over 500 meg of bandwidth. This is important for me to understand to identify with what my users are doing and how they're accessing and what they're using on my network. And then over to the right, we see the link utilization. We give a couple spark lines throughout the period so I can quickly see what applications are using bandwidth. In this case, 11 meg or almost 12 meg of my bandwidth was consumed by Netflix, and it was by host 192.168.111.120. This is something I'm going to want to investigate. So let's get into identifying with the layer 7 application traffic. From here, I can get into, for forensics purposes, my real-time monitor. This gives me an idea as to data in flight. Most people are accessing the Extend Appliance on an ongoing basis to see applications that are running throughout the environment, and then to apply appropriate use policies for the applications to ensure that the application is being used for what is important to the environment. Now, in this case, I see that this particular IP address is using Netflix. This layer 7 identification tells me exactly what the host is doing. Now, I want to get a deeper view. Who's doing this? So if I'm integrated into my Active Directory environment, or I've statically assigned users to IP addresses within the environment, I can go in and show my users. This is important to me because I want to go investigate more about what particular users are accessing what applications within the environment very quickly. This helps mitigate those questions of, why is the network slow? Well, in my case, Netflix is consuming 3 meg of my bandwidth, while other applications are using less and less amounts of bandwidth. This could be potentially a problem. I want to go in and make some modification to ensure that my appropriate use policies are being enforced. From here, I get into my configuration. Now, all of this visibility, and I always like to pause here for a moment for everybody on the call and say, unbox the appliance, put it in the network, define an IP address if you need to, otherwise leave it DHCP, and start collecting information as to what's happening. That's the coffee break implementation. I now get visibility into everything that's going on in and out of my egress point, and I can then make the policy decisions. So at this point, I want to adjust the way that users use my network. By starting with a blank optimization, I can define things that are important to me. I can create my circuit. I can define virtual circuits, which are identified based on network objects or VLANs within my environment. And then I define policies. Well, my first view into Extenda, getting this great visibility doesn't natively make me a policy policeman. So I want to walk through a wizard that tells me what Extenda's best practice is for the topology that I'm representing. Stepping into the Extenda wizard, in my case, I do want to start the optimizer when I'm completed. I do want to enforce control or appropriate use. I get into my control mechanisms, and then I define, based on a profile, what my environment looks like. It's described here as enterprises are a little more restrictive in the way that people use recreational and peer-to-peer traffic. If I'm a service provider, I may be a little more generous with peer-to-peer and recreational, but I still want to ensure that my critical applications are given the bandwidth they need. In today's example, I'll choose an enterprise, and then I select my topology. Again, the Extend Appliance can live in a multitude of topologies, including virtual environments, but in my topology, I'm going to go directly to the internet through a single egress point where all my users live on the inside of my network. That is topology number 1. I define my bandwidth. Because I'm on an asymmetric circuit, that is, it's a broadband connection, I'm roughly 18 meg into the environment, and I'm 2 meg out of the environment. If I'm symmetric, that is, my carrier provides me the same bandwidth in and out of the network, I define both of these equal to whatever that bandwidth is. Now, the Extend appliance can scale anywhere from your lesser bandwidth, sub 1 meg if needed, all the way up through 10 gig, depending on the appliance model that you're interested in. In my case, I'm using one of the smallest appliances, giving me control and visibility up to 20 meg. I apply this, and going back into my configuration and looking at the way that the optimizer has defined policy for me, it gives me an idea as to what those best practices are. Choking peer-to-peer sounds good to me. I don't want people using it. I can modify any of these policies on an as-needed basis to ensure that I do or don't allow specific applications. Potentially, in an enterprise environment, I may not want people to use peer-to-peer, so I simply can go into the policy that's been predefined. I'm a big fan of naming things that are descriptive, so I'll put discard. I don't like peer-to-peer. And rather than optimizing it, that is, putting policies in place to ensure or protect or restrict, I'm going to simply discard peer-to-peer from my environment. The filtering rules that you see down here can define who, what, where, when, and what everything is going on with that particular host. Whether it's a network object, whether it's a user specific to my Active Directory environment, can be defined as my internal, my external, or my DSCP value. I then select the particular application or my application group. By grouping common applications together, it allows you to simplify policy enforcement by placing specific applications into groups. Now, great questions come about, how are these application groups defined? Extenda predefines them. You can modify as needed, but all of our games, our peer-to-peer, our social networking, are all placed into the appropriate policy groups so that I can apply those policies globally. If that's not my interest and it's for peer-to-peer, but more specifically, I want to do it for BitTorrent, I can simply go down to BitTorrent as the application or the individual application and apply policy there. So I'll stick with my native policy, my peer-to-peer, and apply these changes. Once I've applied that policy, I simply restart my optimizer, that is restart the service, and enforce that discard policy that I have on my discard policy for peer-to-peer. Now we had noticed that Netflix was consuming a bunch of bandwidth. Netflix is considered a streaming application. My policy by default, when I run through the wizard, suggests that I need to put a low policy, that is, only give it up to 10%. Let's go review how this policy is defined. So when I limit the bandwidth, I give it 2% of my bandwidth, allow it to burst to 10%. If I don't like this policy, I can simply change it from percentage to kilobits to reduce it even further, or adjust how much bandwidth it's giving. In my case, 10% is acceptable. Now, the differences between my guaranteed and my burst all lie within my burst priority. I'm guaranteeing that 2% is allocated to the streaming application group as long as they need it. It doesn't parse through the bandwidth and reserve it. It's only available if it needs it at 2%. It can burst to unused bandwidth up to 10% of my circuit and can burst at a priority, a very low priority. When I apply these changes, again, ensure that my optimizer has been restarted. Now, looking at my application Netflix, I want to go in and monitor to see how it's running at this point. Well, I see right away, as soon as I enforce this policy, rather than using 3 mega bandwidth or potentially 5 or 7 mega bandwidth, which Netflix has a tendency to do, I'm containing it to 1.3 meg. And on my conversation refreshes, I can see that it's always being enforced to ensure that other applications that are more important get bandwidth. I see that Silverlight has now kicked in as an application. So by applying a streaming policy to all of these applications, I now have control of it. Now, Xbox One, the user, is using too much bandwidth, always or specifically for streaming. They need to get back to work. Let's go in and make a modification to our policy to ensure that streaming is guaranteed some bandwidth, but let's restrict this individual user a little more. This gets into my policy customization. So I'm going to create a new policy. I'm going to call it restricted streaming Xbox. I'm going to give it some bandwidth, but in kilobits versus megabits. And I'll say you can use 100 kilobits of bandwidth, and honestly, you can use up to 1 meg. That's all I want you to use. I'm going to allow you to burst at a lower priority, at a very low priority, because I don't want them to use excess bandwidth. And I'm going to assign it to the user Xbox specifically, and I'm going to do it for the application group streaming. Apply my policy. Adjust where he is in my rule set. I'll move him to a number 9 so he shows up at the top. Reorder him. Apply my changes. And do a quick monitor check to ensure that my restricted policy is being enforced for that particular user. By navigating back to my real-time monitor, we'll give the conversation a moment to back down. And as the policy is enforced, based on my policies that I have defined, I see restricted is now falling within my 1 meg policy. Very quick, very effective way to get control of the bandwidth. I am also interested in what other applications this Xbox One account is doing. Let's get into our monitoring. Identify with the users that are running in the network, going into the time series, whether it's the last 60 minutes, 24 hours, 7 days, current month, previous year, the data is stored as an ongoing basis for you to go and review what's going on. I'll select my Xbox One user, and now I get an idea as to what they're using, Netflix and HTTPS, and what they're sending out of my network equally. If it's interesting or URLs are associated to it, I would see URLs here as well. Let's get into users that are actually using URLs. Let's take Randy T510 as an example. The applications this user is accessing, GoToMeeting, Google Encrypted, and so forth. I'll go down and select the URLs and identify with the URLs that they're running, again, to ensure that the appropriate use policies are being effective. From here, once I've identified, I've controlled, and I've reported on what users are doing, now I need to understand more as to what the reports and the applications are doing in the network. That all starts with Exinda's Solution Center. Now, stepping into my Solution Center, we give you information as far as application performance. And this ties back into my SLAs, or my service level agreements that I have with my company and my users. By default, we give you application performance scores based on business applications, Salesforce.com, Office 365, Adobe Creative Cloud. We also give voice performance scores for anybody that's running voice within their environment. And we have an additional custom application that we can define specific apps that are important to me. In my case, I had seen that Silverlight was an application running. By simply typing in contextually Silverlight, I can create a net new report. This report automatically in the background creates my SLAs for me, creates reports that identify with application usage, gives me my top users automatically. And as you can see, just creating the report right now, I see that this amount of bandwidth was consumed. To the right-hand side, I see my internal hosts based on IP and my users and who they're communicating with externally, whether they're internet-based or whether it's a remote environment. I get information, how much WAN bandwidth and LAN bandwidth was consumed, how much bandwidth was being utilized out of the network, and total outbound bandwidth. I get an idea, which I will show you, application performance scores. This is a time series performance score. I need to let it collect information. So I'll drive into a different application that gives you some information on it. And then again, more information on the hosts, sortable based on name, user, or total volume, or average throughput. So let's look at Netflix as an example. I've created an application performance score based on Netflix. Netflix was consuming up to 7 meg at a period of time. And I can see, based on the usage, it was this user, my .120 Xbox One, and he was consuming the majority of bandwidth. I can see the performance scores based on the automatic identification as to how this application should perform And when I scroll back to the top of this screen, I can see that my application performance score has been dropping dramatically. It was starting near a 10 and started to fall off on a regular basis. To get more information on my performance scores, I go into Show More. From there, I can get information on my network delay, my server delay, my round trip time, my jitter, anything that's important to me to identify with what good looks like in my environment, and get a pre-notification when bad things are occurring. So in this case, I would be receiving email alerts that my network and server delay have dropped to a substandard level, and my normalized network delay is dropping in the yellow. Additionally, if I have voice running, I can look at my voice performance scores to get good, callable, and bad calls. In my case, voice is not running, but this would give me an idea as to the voice conversations that are occurring. If I look at the last 7 days, I see here are the voice conversations that were occurring at periods of time, and who the worst conversations were to and from. From there, it goes on to an ongoing monitoring, whether I'm looking at my network interface usage, my applications, users, groups, and then creating scheduled reports so I get updates daily, weekly, monthly, whatever period I need to identify with what's happening in the environment. That's the coffee break implementation for Exinda. I'd like to turn it back over to Ashley for any questions that have come up. Ashley?
Thanks, Randy. Thanks, Randy. I'm checking right now to see any questions. Let's see. It doesn't look like I have any questions on here right now. Oh, wait, here one comes in. The question is, can I manage user policies from Microsoft's Active Directory?
That is a great question. Let me answer it this way by showing it. When I get into my users and groups, if I'm tied into Active Directory, my Active Directory groups will show up in my policies. Now, this particular Active Directory environment doesn't have any groups that are associated, so it doesn't have them. My apologies. But if they do show up in here, I can, within my Active Directory environment, for instance, take IT professionals that are at all of my remote locations, and regardless of where they are in the network, they need a higher precedence or a higher priority on the network. I would simply define what group that is within Active Directory, move those users in there, and then within my policies, under my optimizer, I would define what users those are, as I did with my restricted streaming for Xbox, to be a group of users to ensure that they fall into a policy. Now, the way that integrates with Microsoft Active Directory, rather than writing policy towards it, you move users in and out of the policies that you've defined that are important to your environment. Next question.
Okay, the next question is this. I am a service provider. Can the product allocate Layer 7 policies automatically based on time of day?
Great question, and yes, it can. We have schedules, and you can define those schedules. Once you've defined the schedules, by default, out of the box, we give after hours, always, and work hours. So if I'm in my optimizer, and I have a restricted policy for my streaming Xbox, it might just be during the work hours. So during my work hours, I want to enforce this policy. But after that schedule has been completed or the time of day has expired, my policy will turn off on that, and the user will then get back into, if you will, the streaming under the normal policy that's enforced.
Okay, the next question I have here is, doesn't this introduce a single point of failure on my network?
That's another great question. Exinda's deployed in a transparent bridge mode, and we are fail to copper or fail to glass in a fiber situation. What that means to our customers is in the event of a hardware or software failure, the Exinda appliance becomes a pass-through appliance. We fail open. Data passes through us because our relay is built on a software driver that has to be engaged by the Exinda operating system. If the operating system isn't running, simply by power or the software has failed for some reason, it fails that connection open, again, both in copper and in glass, i.e. fiber, and allows traffic to pass through the network. Now, if it's important that the appliance is controlling traffic, we can fail that connection closed, but natively, out of the packaging, it's fail open.
Okay, we had another question come in, and it's when you're changing policies, is there any disruptions to the network?
Another great question. You've got some great people on the call today. There is not. Although there is a service restart, so on multiple occasions you would see me go up to this restart service, it's a simple restart of the service on the optimizer to enforce the new policy changes. So all of my other policies are retained, and only the changes that I've made are affected, i.e. my restricted streaming. I added that user. Now I want to enforce that policy for that user, so simply restarting it does not cause an outage. It simply applies the policy change.
Okay, and we have another question. They're wondering where they'll put the Exinda box in their network.
That's something that both Pulse and myself, Randy Hunt, with Exinda Networks can assist with. Your topology, if I go back to my topology views, I had brought up that there was a couple different ways that I can see my topologies. Let me see if I can go start from this slide. So depending on where I'm at or where I need to place it, we will assist. Insert as much technology as you would like. If on the inside of my network I have a hardwired switch, and as well I have a wireless network, for instance, that connects through a different connection point, I could add multiple bridge interfaces to this Exinda appliance. On our smallest solution, we have 2 bridge interfaces. On our largest solution, we have 15 bridge interfaces. So depending on your topology and how many connections you need depends on not just the size, but how we configure the appliance to ensure that it meets your needs. If I want to add in here a VPN concentrator, if I want to keep stacking on, I'm doing link load balancing, maybe out here, it all depends on what is important to see for you. Again, as a preference or as a systems engineer, I'm always interested in interesting data. If I place the Exinda on the outside of the firewall, I tend to lose some visibility because the majority of the environments I get the opportunity to participate in have network address translation enabled at the firewall, so I see everything to and from one point. Being on the inside of the firewall, inside of the VPN, inside of the content filter allows me to see all of that information that's going to my egress point to my router.
Okay, thank you, Randy. We have another question. If the total bandwidth is 2 gigs, can the system handle that?
Yes. So in the Exinda appliance, we can handle up to 10 gig, and that can be in the form of multiple configurations. In a 2 gig environment, I might suggest that that would be 2 trunked ports to give me 1 gig per carrier, for instance, or per leg of the network. It might be a 10 gig interface that's partitioned off for 2 gig. Whatever that topology is allows the Exinda to see the data. Again, if it were 2 1 gig trunked connections going to 1 or 2 routers, we certainly can support that. We have, excuse me, we have what's called global QoS to manage that bandwidth as if it were 1 pipe.
Okay, it looks like that's all the questions that we have today. Randy, could you go to the last slide so we can put our contact information up there?
Certainly. That should be on your screen now, Ashley.
Okay, thank you. And thank you, everyone, for attending our workshop today. This presentation will be available on our website shortly if you'd like to go back and review anything we went over. And if you have any other questions, you can reach out to Bobby Bain or Randy Hunt, and their contact information can be found on this screen right here. Again, thank you for attending. And thank you, Randy.
You're welcome. Thank you, everybody.